Okay, let's do this. Welcome. I'm really happy to see so many of you. Thought it was going to be like 2 or 3 people. My name's Johan. I'm 42 years old, so basically the answer to the ultimate question of life, the universe, and everything. I've been programming since I was 9 on the VIC-20, C64, Amiga. Then, of course, I studied political science and economics, as you do. And then I got back into programming again. The talk has the really short and succinct title of Why Promising Nothing Delivers More and Planning Always Fails. I've given this in Swedish, and then it was simply called Köp grisen i säcken. So that's sort of a bit more to the point, but I think this works. The main question that this talk revolves around, or the main problem, is this. Why do so many IT projects fail? And you all know this because you've all seen them fail, and fail miserably. There's a really popular image that goes around the internet which looks like this, which sort of describes what a lot of us have experienced when it comes to doing IT projects. And I think it captures it pretty well, but it doesn't answer the why. So let's look at a short history of why we got here. So let's look at the history of the corporate web. It started off like this. Okay, this was the corporate website. It was basically something telling you that we have the goods, so come here and buy them. That's what it did. But then it evolved. So we did the same thing with Flash. But if we look at where the corporate web is at the moment, and this sort of tends to describe most IT systems, they sort of look like this. It's the everything in the kitchen sink. It's your public-facing means of communication. It's your staff, it's your product, it's the possibility to buy, it's customer services. Everything is in the system. And of course that's a good thing because we need to solve it, but the problem is when we do this, we create complexity. And complexity leads to risk. And risk leads to risk management, and as you all know, risk management leads to suffering. Why is that? Well, let's have a look at managing risk. What does that mean? How do we manage risk? Well, what we try to do is to sort of start by defining the problem. If we understand the problem, we can measure the risk, we can manage it, okay? So we define the problem in as fine-grained detail as we can. And then we estimate that. How much will this cost? How much time will it take? And then, of course, we realize that we don't know everything yet. There are some unknowns in there. So we sort of try to estimate those as well, and then we sort of multiply them by pi, and we feel happy. Because now we can go into negotiating a contract. Because we know how much it's going to cost, we know the risk, now we can get rid of it by putting it into a contract, a legally binding contract. So what we end up with is this, which is called the iron triangle, where you have your fixed budget, because we know how long it's going to take, right? We have the time, and we have the scope, the set of features. And hopefully, somewhere in there is some sort of quality. But that's usually the only part that we never sort of estimated or defined, but it should be there. And then we start building, and inevitably, this happens. The scope grows, and since nothing can give, the only thing that can give is the quality. But that's not really clear why. Why is it the quality that gives first? Well, one thing I realized, because as I said, I studied economics, was that we have a fundamental problem in doing this with what's called risk allocation. Because when you invest in something, you always know there is risk, otherwise it wouldn't be worth anything. But you have to allocate that risk, and you want to allocate the risk where it's the cheapest, where it's at its lowest possible. So let's see what happens with the risk allocation when you do these types of projects. So we have basically two parties. We have a client and a contractor. This actually works within organizations as well, where you have like business and IT. And these parties are not really equal. Then we have two types of risk, two main types of risk that we have to manage. We have the economic risk, as in we go over budget. And we have the functional risk, as in it doesn't work. Now, the cost of risk differs between these two parties, because the contractor or the IT side are usually not the guys with the money. Contractors are usually smaller than their clients. The IT department is on a tight budget, and the business side is what brings in the money. So we have basically a higher economic risk on the contractor side. They are more sensitive to economic failures. When it comes to the functional risk, though, that's basically not a problem for us as programmers. If something doesn't work, we can change it. We can fix it. But on the client side, the risks can be astronomical. Because if your web shop breaks down in the middle of Christmas sales, you could lose millions. So we have a really, really high functional risk on this side. But what happens when we make this contract and try to fix every single part of the puzzle, what we do is we push the economic risk over to the contractor side. If it fails, it's the contractor's fault. It's IT's fault. They didn't manage their budget. So we push the economic risk there, which means that the only way for us to defend ourselves is through the functional risk. Because we know how things work. People buying stuff from us do not know how things work. So that's the only thing that we can get away with. So we push that over to the client side. And it doesn't have to be like that we do it maliciously, but we do it subconsciously. We try to hide problems. We try to not see them even for ourselves. We might realize that there is some weird corner case here, but better not bring it up, because we're out of money as it is. And that's a problem. But the interesting thing is that this is our smallest problem. The biggest problem we have is that when you're working with fixed requirements, it leads to bad products. Why is that? Well, what you're trying to do with the fixed requirements is you try to plan in advance. And there's a lot to be said for planning in advance. If you have the map, if you have the tools, you can probably predict what's going to happen. But then again, you all know that this is seldom the case. Sometimes, or a lot of times, it turns out that reality differs from the map. And if we're stuck with following the map, we're going to have a really big problem. So let's go back to this. Why did this happen? Well, basically, because there is one single outcome here, which is the correct one, and that's the tire swing. That's what the customer really needed. But let's have a look in the beginning. This is how the customer explained it. Okay? So there was no way of knowing that this was the correct product. This is basically the only outcome that's impossible in this equation, because we fixed the requirements before starting to work on it. So we can never find that. It's in the contract that we can't find it. So then I started thinking, like, why is this? Why do we get stuck here? Because this is counterintuitive. No one wants this, right? And I think it's due to something that's called the streetlight effect. The streetlight effect is actually It comes from a comic strip. There's a drunk guy beneath a street lamp and looking for something, and the police officer, it comes in different variations. He dropped a nickel, or he dropped his keys or whatever, and the police helps him to look, and then finally gives up and says, "Are you sure you dropped it here?" "No, I dropped it over there in the park." "So then why are you looking for it here?" "Because the light is better here." And this seems pretty stupid, but this is actually what we tend to do all the time. We know that we should be looking over there, but there is no light there, so we might as well look here where there is light, even if we know all the answers we're going to find are wrong. So what happens is that we start to focus on stuff that is easy to measure. So we focus on the budget instead of focusing on the return on investment, even though we know it doesn't make any sense. Because if it costs $10,000 and gives you nothing, it's crap. If it costs $10 million and gives you a huge return, it's really valuable. So the return is the only thing that's interesting. But we still focus on the budget. Why? Because there is better light there. It's easier to see the budget. And we focus on the cost of a feature instead of the importance of a feature. Even though we know that if the feature is really important and not there, we're going to lose our customers. Why? Because the light is better there. It's easier to measure the cost than to measure the importance. We focus heavily on quantity and almost never on the quality. We look at the burn-ups instead of looking at the actual speed with which we deliver features to the customer. And all of this is just street lighting. We know that these numbers are wrong, or at least irrelevant, compared to the numbers on the right, but we still do it because it's easier. And then we can get better numbers, and then we get better confidence because we think we're managing the risk, whereas we actually are just making a worse product. So, how do we get out of this then? Is there a way? Well, I think there is. One way to look at this problem is to, and this is sort of a cliche, I know it, but bear with me, is to look at the mindset of a startup entrepreneur. What do they do that's different than big old organizations? Well, for one thing, they're usually driven by a very well-defined idea. But the path is often unclear. They don't know yet because they haven't invented it yet. So they have to be open to altering the path, but stay true to the idea. They focus on working with a very dedicated team because they won't get it done otherwise. I mean, like imagine the programming by the pool in the Social Network movie. That sort of thing, compared to what resources are available in IT at the moment. So the focus is on the dedication in the team. They have a huge focus on time to market, because if you're trying to invent something, if you're trying to change something, to disrupt something, if you don't do it in time, you might as well not do it at all, because someone is going to beat you to the punch. And since they're funded usually out of their own pockets or from venture capitalists, they have to produce continuous and visual improvements. I mean, it doesn't matter if like I shaved 10 milliseconds off the call to the database if you can't see any difference. And it doesn't matter if we were moving fast in January if we're standing still now, because you're going to lose the confidence of your investors. And of course, the return on investment always trumps the budget, because this is a high-risk project from the get-go. So it's always been about the returns. And then if you're a venture capitalist, you're always dealing with risk. So you do realize that failure is always an option. If it wasn't, then everyone would have done it before. So how can we take these learnings and bring them into the bigger, the older organizations? Well, if we just start with like the easiest thing in this equation, it's probably about building the minimum viable product. Don't build everything. Build the minimum required. And everyone says that. And everyone, or a lot of people claim that they're doing this. The only problem is that we usually do it wrong. So this is not how you build a minimum viable product. There is nothing there until you're done. There's nothing you can ship until you reach stage 4. This is how you build a minimum viable product. Because every step of the way is releasable. And the release is usually the first point in time where we can start to gather actual metrics on the returns. And that's the number we're after. So we need to get out there early. So we need to identify these steps where we're releasable early and then can keep iterating and making the product better. But in order to be able to do that, we have to understand what the goal is. So in the picture before, you might assume that the goal was to build a car, but it was not. The goal was being able to move people from A to B. And then you realize that the first step might be a skateboard. That will move them from A to B. They can't bring groceries, but that's okay, we'll add that later. And the really good thing about this is that when you get the skateboard out there, you might realize that what you should be building is not a car, it's actually a hoverboard. And now you're gathering the metrics to be able to see this. So, let's just assume that you all buy this. Okay, we're going to do this minimum viable product thing. We're going to release early, we're going to release often, we're going to collect the metrics, we're going to listen to the customers, we're going to change what we think we're doing based on what they like and what they don't like. Then you need this. If you're going to be releasing all the time, it can't be a major cost. You need it to be cheap, you need it to be fast. And the really important part of this is that this makes release into a business decision. We used to releases being like these horrible death marches of 24 hours of migrating databases and just being scared and then rolling stuff back. We can never sort of give that decision to the stakeholders. But if you can get a zero cost of release, you can make it into a business decision. If someone, we're used to saying like, we don't release on Fridays because the weekend is coming up. I say you should be able to release on a Friday afternoon after having a few beers. But how can you achieve that? Well, what you need to do is to build the confidence. So in order to have something to release automatically at all times, we need to get continuous delivery in there. Every piece of code that's pushed to the master branch should be turned into a build artifact, which we can just release at the push of a button. So how do we do that? Well, we need to be able to trust the code if we are to do that. Otherwise, we'd never release it on a Friday. Otherwise, we'd never leave that decision to the business side of the company. But if we have good enough automated regression tests, I can actually be fairly confident that the code that I just pushed actually works. So now if someone asks me if I'm ready to release, I'm like, hell yeah. But you can't just do those two. You need to build a stronger foundation in order to get there. So let's add the continuous integration part. The part of the system that always tells me how things are looking, so I know early if I'm going in the wrong direction. And then a continuous and fast test runner. And these are usually treated basically the same way, and people have conversations about which one should we prioritize. If we have to choose one, which one should it be? But you can't do that, because these are actually very different things. This part is all about building the confidence, believing in that the code there is releasable at all times. That's the confidence part. That's not about being fast. This can take hours, it's okay. If we can throw more machines at it, that's good. If we can get it faster, that's good. But it's about building confidence, about building trust. So if we need more tests and they will take longer to run, then we'll have to let them. Whereas this part is about speed. This is about telling me early that something is wrong and that I need to change it before pushing it. Something that constantly tells me if I screwed up somewhere. Something that constantly tells me if the result of me and another developer pushing code are in conflict. So this is the feedback loop to me as a developer, whereas the other steps is the feedback loop to the business side, telling them that they can trust what we do. So if we do this, if we are ready to sort of start looking at the actual numbers that matter, if we are prepared to put the tools in place to make it possible to do early and frequent releases, something very interesting happens. Buzzwords, NoProjects. That's an interesting hashtag on Twitter. The thing is this: if we look at what a project is, I sort of Googled it and picked the sources that seem most reliable. So, I mean, you can trust anything on the internet, right? So, the Project Management Institute defines a project as a temporary group activity designed to produce a unique product, service, or result. And Prince 2 says it's a temporary organization that's needed to produce a unique and predefined outcome or result at a pre-specified time using predetermined resources. Which sort of goes against everything that I've said so far. Because if we release the skateboard, we've already sort of owned up to the fact that we don't know how long this is going to take. We should keep doing this as long as it gives more revenue. And we should stop doing it as soon as it doesn't give any more revenue. So it's not a predefined time period. The predefined temporary organization parts, like why should we suddenly exchange all the programmers for new programmers just because the time slot runs out? It doesn't make any sense. It's not a predefined outcome. So everything sort of falls. And I'm not saying that we have to make major changes, but I think that the focus on the project model sort of blinds us to the fact that it's not a project. But we tend to follow the metrics of a project model even though it's wrong. So I think we should watch out for treating development as a project and start looking at it as investment. The other interesting hashtag, and this is actually one of my favorite, is this, NoEstimates. This started out as a different hashtag. The hashtag was estimates are wrong. That did not work. Can anyone guess why? No one disagreed. Not a single person got upset or thought that they were full of shit. So, of course, the hashtag is meaningless. So they changed it from estimates are wrong into no estimates, and Twitter exploded. Because the same people who were just in agreement that the estimates were wrong were now screaming at the top of their voices, going, "We need them! You can't remove the estimates!" But You just said they were wrong. Yeah? So why do you need them? To plan! So you want to plan from numbers that you know are wrong? Yeah? Why? Well, we haven't got anything else. And that's sort of the problem. But that's again the smallest problem. The biggest problem isn't that estimates are wrong, as in they predict the wrong outcome, because sometimes they can predict the correct outcome. The problem with estimates is that it tends to fix us on a specific idea. It tends to make us less flexible and less changeable when we realize that it shouldn't be done this way, it should be done this way. Because suddenly when you change the requirements, you get a penalty, because now your estimates are off. And the other problem with this is that we sort of tend to get lazy. We look at something that's far too big and we go like, I don't know, 8. And then when you start working on that 8, you have to start discussing, what is this? What do we need to do to achieve this? What are the steps involved? So why do we say 8? It's a bit of inception. This is a picture from a talk at RDev by a guy called Vasco Duarte, who was the guy who set me on to NoEstimates movement. And his picture of the process is this. So we select the most important piece of work that we need to do, okay? Because we focus on what's valuable. Then we break that work down into risk-neutral chunks of work. The risk-neutral part is the really interesting thing. I'll get back to that. Then we develop each piece of work, and we iterate and refactor. But then what is risk-neutral? Well, basically, risk-neutral means that you do understand the ramifications of this unit of work. You can sort of foresee what it's going to entail. It's broken down so that you understand it completely before starting to build it. Which changes the way we do poker planning. So now we just have these 3 sizes. It's either a 1, because you understand it, it's risk neutral, or it's too fucking big. Or you have no fucking clue. So what you do then is you attack like the user stories or the features or the stuff that you want to release, and you go, is this a 1? No, it's not. It's too fucking big. Is there any part of this that we could break out and call a 1? And it's like, yeah, well, this thing is a 1. Good. We put that on the board. Now is it a 1? No. So we break it down again. And we keep doing that. And then sooner or later you encounter some stuff that he goes, no, I have no fucking clue. So we put them in their own pile. So you know that this is the really risky part. But now we know what we're supposed to be doing. We know what the risks are, and we can attack those by doing spikes or just doing proof of concepts and see if we can gather more information so that we can turn them into 1s. And then we just do them. Because we've already started off with saying we're going to do the most important thing first. So we know that we're doing the right thing. And now we know what we're doing. And we're having the conversation around what we're doing instead of whether it's a 7 or an 8. But the really interesting part is this. Now you can actually start to measure the throughput. And since everything in the system is 1, you can start to collect metrics over time. And you can say, okay, we basically finish like 16 ones in 2 weeks. So if someone asks you, will you get this done by the next sprint? You can look at it and you go, that's 20, no? And they're like, please. And you go, sorry. We usually do 16. I see no reason that we suddenly would be able to do 20. Because you have the metrics. This is not guesses. This is actual units of work. So you need to convince some people that, okay, you will be lagging 2 weeks before you get the numbers. but the numbers will probably be correct, and we won't be spending any time just guessing stuff. And it actually works. They do buy that. Yep.
Do the ones actually take, in average, equal amount of time?
Yes, they do. Oh, sorry, the question was, do the ones on average take an equal amount of time? Yes, they do, and it evens out. So if it's like 2 days or half a day, it usually doesn't matter. When it comes to the size of the project, it sort of gets lost as noise. Yep. An example of a good one or a bad one. Let's see. Trying to think back to the last time we did this. Yeah, it was basically we were defining an API, and it was like, so we need to be able to log into the system and get the basic user information back together with a token to access the rest of the system. And just the by then we had the database, and like the infrastructure was there. So it was basically just building the API part of that. So I was like, yeah, we need the token. Yeah, that's the one. I can do that in roughly 1 day. Might be a half, might be 2, I don't care. Because it doesn't actually matter, because it evens out. But it's small enough that it's not like possibly 3 days, I don't know. And that's sort of the point. And the thing is about a bad one, I think it's actually sort of the wrong question. Because if you really try to define something that you understand, and you fail at that, that's okay. As soon as you put up your hand immediately and say, we totally overlooked this. This is not a one. This has these elements of risks that we just didn't foresee. And so you'll have to reevaluate that. But the thing is, you already know that this is an important feature that's going to bring you some sort of revenue, which means that it's actually okay if it costs money. Not any amount of money, but the stakeholders can see the progress, which means they can pull the plug in time if it turns out that you're wrong all the time. So, how to start doing this? It's got all to do with confidence and collaboration. If we look at it from the contractor's perspective, it's about the confidence part. Our client has to have confidence in us so that we can say we were wrong about this. But they have to have the confidence not to put all these checks and balances in place to hinder us from learning. So how do you create that confidence? Well, the first step that we usually take is this. The client owns the code. And this is strictly in the contractor perspective. When we get a new client and they want to know about source control or like where you keep the code, we usually just say, okay, we'll help you set up a GitHub account, which you own, and then you let us in. So you can throw us out at any time. You have the code, okay? No lock-in. We've achieved that with the code by this time. They have the code. They have the build service. They have everything. It's theirs. We're just allowed in as long as they trust us. But we also need to make sure that we don't lock them in other ways. Because then they need the checks and balances back again. I was talking on the phone with one of our clients and about the contract, and they wanted to put in some clause there about differentiating bugs from feature development. And I said, well, you can't do that. Why? Well, because then we have to know everything in advance, and then we have to start planning more, and then we can't try stuff out, and then we'll be slower to the market. It's bad. So he says, but shouldn't you work as friends, but have a contract as if you're enemies? And I said, no. You should work as if you're friends. You should have a contract as if you're friends. And if you're not friends anymore, you should stop working. Because then you won't produce any value. So he goes, so what you're telling me is to write a shorter contract. And I'm like, yep. How short? Well, we're pretty booked up. So what you want to do is you want to write a contract that's long enough for you to be able to trust that you can have the resources that you want, that we can't sell them to anyone else before you, but as short as possible so you can always change your mind. Because we are confident in what we deliver. And now we need to show it to them and say, here's the trust. We're going to be good, so you won't kick us out, so we'll make it really, really, really easy for you to kick us out. And it might turn out that we're wrong. It might be that we're really, really bad at delivering to that precise client because it doesn't work, like the chemistry between us or the problem space, I don't know. Then we should stop working together because we don't want to produce crap, we want to produce value. We need total transparency. This is all about getting rid of the politics. It's not about managing the politics, it's about getting rid of the politics. You need to be able to go tell the client, see, look, I thought this was one, it was not. It was significantly bigger. I was wrong. Because if you do that, they will actually start trusting you when you say you're right. Because they know that when you're wrong, you'll tell them. And you also need to make it visible for the client what you're doing. We were working with one customer, and we had some problems with the build server because he hadn't paid for the build server. And the first 50 builds were free, and then it stopped working because he hadn't paid for it. So I called him and said, well, you know, I'm writing an invoice to you now, and I actually have to spend time telling you what we've done. I don't want to do that. I want to write an invoice that says stuff. And you should know at every point in time, every day of the week, you should know exactly what we've done because you should be able to see it. So we need this build server up and running so that every check-in actually results in a build that you can see. Because now I don't have to tell you. Because if I have to tell you, it might be too late. Now you can see for yourself, so you can just call me or come over and say, you're going in the wrong direction. Or, I just realized we're both going in the wrong direction. It's total visibility, total transparency at all times. Constant and consistent quality. This is really interesting. As we gain knowledge about a system, as we understand more about it, the quality should be getting better. But it rarely does. It usually goes down. Why? Well, because we change. We learn new stuff. So we need to go back and change stuff to keep it consistent, to keep the quality high at all times, because otherwise we will slow down and we won't be able to change. Minimal cost of entry. We need to be able to bring in new people. Our client needs to be able to bring in new contractors at a minimal cost of entry. You need to have like a README file that tells you, in these 7 steps, you set up the entire system. That's a minimal cost of entry. I mean, I might be run over by a bus tomorrow, you never know. I need to be able to be replaced, because obviously that's going to be what's on everyone's mind. As I said before, 0 cost of release. So the other side then, the collaboration part, the client's perspective on this. What do they need to do in order for this to work? Well, the first thing is do not negotiate price. Why? Because we cost what we cost, and it takes the amount of time that it takes. So what's there to negotiate? This might sound like something that we're giving to the client, like a gift to them. You're in control. But it's actually not. This is a requirement on the client. They need to be in control. Because we know our business. We know technology. We know how to solve stuff. But we don't know their business. And that's the problems we have to solve. So they have to be in control. And sometimes they'll tell you, I just don't have the time. And you can just reply, so it's not an important project then. Because if they don't have the time, well, why should you do the project at all? If it's supposed to bring in money, and they don't have the time, they have their priorities wrong, or it's actually a project that shouldn't be done at all. Minimum viable product, as in minimum viable product. The two words that sort of are that we can struggle with here as programmers is the viable part. As the customer is usually the minimum part. It's like, do you really need this feature for anyone to start testing this? And you have to fight them on that. And you have to keep returning to what is the goal. Is it really a car? No, it's about transporting people from point A to point B. A car is not a minimum viable product. And you have to dare to fail. You have to realize from the start that you might fail, and you have to dare to fail, and you have to stop blocking out the signals that you're about to fail. SEB spent 1 billion Swedish kronor before they failed. Wouldn't it have been great if they could have failed after 100,000? But you tend to block that out because you're scared of failing. You have to embrace it. Because you have to do it in time. So, quick summary. Fixed price projects are bad risk allocation. Fixed specifications give bad products. Because you should focus on what matters, not what's easily measured. Release early and often with zero cost. Don't be constrained by the project model. That's just interesting. Don't estimate. Like really, don't. It's focusing on the wrong problem. It doesn't help you. And build the confidence that you need to collaborate. You have to put yourself out there. You have to build the trust. So where do you start? Well, understand the goals. And then you focus on the goals. You need both. You need to prioritize your environment. As in, use TDD, have a fast test runner, put time into that, make sure that you have a good environment to work with. Make sure that you have working continuous integration. Make sure that you have continuous delivery, because it's going to keep you speedy all the way. And if you can't change the project, change the project. Life's too short to be delivering crap. You want to deliver value. So if you can't change it, go somewhere else. There's a huge shortage of programmers. This is not a problem for us. We can do what we love and produce value from that. Thank you. The speaker score thing, I have no idea how this, if it's good. I found it while in the bathroom, and I didn't have time to be in the bathroom long enough to try it out against other products. But it's for rating the speech, so I would be very happy if you were to do that. Does anyone have any questions? Oh.
So you figure out the minimum viable product, and the customer asks, so it's 1 million, 1 billion, or no clue? Do you give some ballpark yet, or how do they sign up with something?
So the question is this: if you figure out the minimum viable product and the customer wants some sort of ballpark figure, is like 1,000, 1 million, 1 billion, what do you tell them? Well, what I would tell them is I would do this, not to tell them what it costs, but to sort of give them a recommendation of how much money they should put in to get started, so we can start measuring how far we come, how complicated it is, and how much value we can deliver in the shortest amount of time, to give them the metrics to decide whether to put in more money or pull the plug. Because that's the important part, to be able to pull the plug. A small loss isn't that big of a deal. Anyone else? Huh? The question is it hard to find customers that are willing to work this way? I thought so. I really did. When I tried this the first time, I was shit scared, and then we were talking about this, and we're like, yeah, we'll go with it. We don't know if it's gonna work, but it turns out they love it. It's like when you talk to mature organizations who understand this, they want this, and they want this really, really bad. So what we're actually doing now is we're hiring more people, and we're turning down customers at regularly, and we always turn down customers who are non-willing to work this way because we can't produce value. But there are enough of them out there. And the rest of them are going to start looking at the ones who do this and want to get on the bandwagon. Yep.
In order to do prioritizations, what do you replace estimates with?
In order to do prioritizations, what do you replace estimates with? Well, that's the whole point. The estimation part is not part of the prioritization, because we're working in a business where we can expect revenues offsetting costs by a factor of 10. If we save hours per day for people working somewhere, and they can spend those hours doing other stuff within the company, it's going to give them huge revenue. It's going to save huge costs. If we can get their delivery pipeline better and the site faster and people start buying more stuff, it's going to give them huge revenues. So it's actually not about the cost, because they don't differ that much. You should always focus on what's the most important thing for the product. And then you try to build it as simple as possible, and then you expand it. And of course, sometimes it's not a 10 times offset, and then you shouldn't do it.
So essentially, importance trumps cost.
Yes, importance always trumps cost, because revenue trumps costs. Anyone else? Oh, thank you.